Hello, everyone. Welcome to our presentation. This is Observability without Oversharing. Thank you for joining. We'll start by introducing ourselves. I'm Joaquin Rodriguez. I'm from Microsoft. I live in Austin. I'm a software engineer. I work with customers doing all things cloud and AI. So you want to go next?
Here is Amin Espinoza. I live in Mexico City, and I used to be here, but the updated slide is like this, ex-Microsoft, because I was part of the layoffs. I couldn't have the chance to update the badge, but yeah, I will be presenting anyway.
Okay, so this is going to be an interactive workshop. Everything we're going to do it live. And there's no pre-recording, so hopefully the demo gods are good to us today. So in order to get started, since this is a hands-on workshop, the only thing we ask is if you go to, and if you choose to participate, to go into that website, and then you put the password, and then you provide your GitHub username. That way you can get invited to our organization. That way you can get free access to code spaces. We'll be using code spaces for this workshop. That way you can follow along this hands-on workshop. Once you do that, you're going to get an invitation. So just make sure you click accept. And once you do that, then you'll be able to access the repo is public anyways, and you can use a dev container if you choose to. But it's a lot easier to do it via code spaces because everything's already pre-built with all the tools that we'll be using during the workshop. Basically what I just said. So once you do that, and you join the org, you're going to see a repo that looks just, yeah, let me zoom in a little bit. Is that better? Or is that too much? No. I think that's OK. Everything good? OK, so once you join, it's very simple. All you have to do is click on code. And you're going to see this tab says code spaces. And then you're going to click this little plus. And all it's going to do is going to spin up a VM for you with all the tools that you need. If you're not familiar with code spaces, so basically it's just VS Code running in a VM on the cloud, and it's already pre-built with an image with everything that we need. I think the light is a little too bright. What do y'all think? Should we try to turn it off a little bit? How do I do this? Lights. Is that better? OK. Yeah, let me go back to the, sorry. So this is the URL. And then it's going to ask you for a password. And that's going to look like this. Right, so you put that password. And then you just put your GitHub username. And so, everybody good? Amsterdam 25. 25? Yeah, it's on the slides. OK, good. So, well, you want to start it?
There is one reason why we started with the code space and then we started the presentation. Something important is that the code space is going to take like 3 or 4 minutes to be deployed. So in the meantime, we can start explaining what we are trying to achieve here. The most important part of an AI agent is how to control it, how to handle how many information is giving back, and all that stuff. And something important, if we don't monitor this information, probably we can spend way more money than we are thinking. So something important is adding observability to our agents is going to let us know how much the information is flowing between the user and the agent. And putting one extra layer in the observability part, we need to consider the privacy stuff. The privacy stuff is when the person is sending information like the name, the phone number, the email, it needs to be handled in a confidential way. That is super important, not only for the security, but also for the reputation of our project. So it is really, really important to keep really a big consideration of that. That's the reason why we decided to do this workshop, because in so many of our projects, we decided to not use observability, and the projects at the beginning were really expensive because we were thinking like, okay, we have like endless tokens, or we have like endless budget, and that's not the idea. If you want to make a sustainable project, you need to consider all the time the money you're investing and the data you are using in order to keep a better track, and also keep all the information you need to have some improvements in upcoming versions. That's the reason why we decided to go really, really focus on observability.
Thank you, Amin. Oh yeah, the password is Amsterdam 25,
There you go.
and that's the workshop URL. Everybody good? Anybody has any issues so far? Okay, good. So, okay, we have observability, but then at the same time, there is a privacy paradox, right? Obviously, we do need to monitor everything. We need to keep, track of how things are performing. Are they up? Are they down? How many tokens are we using? How much is it going to cost? But something that we need to also keep in mind is that, well, we cannot store sensitive data, right? There's a lot of rules and regulations like HIPAA, GDPR, et cetera, that prevents us from, storing sensitive data. So we need to be more mindful on how we implement our solutions. And something that we're going to show you is one way of doing it is, how we can implement privacy-preserving observability. So in this workshop, the goal is to walk you through some exercises, set up a basic stack of tech, and then at the end, set up some observability, and then finally put some privacy-preserving techniques. So for today, yeah, that's me. We're going to be showing first a simple, very basic chatbot CLI that is going to be interacting with a backend API, right? And then this backend API is going to talk to an LLM. In our case, we're running Ollama using a small language model because this is going to be, again, a workshop. But if you, by any chance, have access to like an Azure OpenAI, you can do that as well, but you don't have to. Everything's already set up with Ollama, so that should be perfectly fine. So that's step one. Step two is to implement the observability stack. So we're going to guide you how to set up an OpenTelemetry collector. And by all of these components, we will be explaining to you what each one is in detail. But this is just an overview. We'll be also setting you up with Prometheus, with Tempo for traces, Grafana for dashboards. And then at the end, we'll be basically implementing some analyzers and anonymizers for the prompts. That way that they can detect, if this prompt that we're passing in contains personal or sensitive information. So, for example, like you can see that, hey, my name is Bob, and this is my email. At the end of the day, we want to, redact the email address, or depending on whatever policy that you set up. Okay. So let's do this. For the first lab, Amin is going to take care of it. So Amin, if you want to take it over.
Are we already in the... This is it, right?
Yes.
OK, so if you have already deployed your code space, this is what you'll see. And those are the instructions. We have in the same repository all the 4 laboratories that we will be running, and this is the first one. If you want to go to the README, there is a lot of stuff there. We wanted to have a lot of detail, so I'm going to focus mainly on the commands we need to deploy to follow the whole structure of the laboratory. So I'm going to go here for the first one, labs, the baseline. The objective of the first lab is just to deploy my agent. No observability, no privacy, no anything. Just deploy my agent. So what I'm going to do is just first move to one readable structure. And as you can see, there is an overview of the architecture that we will be having in this stage. The idea is just having one interface, which will be a CLI in this case, and going to the agent and have some basic interaction. That's pretty much it. So if I go a little bit down, you can see the providers that we can pick. As a matter of fact, we can, like Joaquin said, we can pick Ollama or Azure OpenAI, and there is no problem in either way. So let's go first to the step number one. Step number one is there is one emb.example file, and we just need to rename it. The idea is just keeping the emb file. One observation we need to put here is that we will be running Ollama. You can see here, and the model we will be using is 54-mini. And this is the base URL that you will be having. If you have played around with Ollama, you consider that there is nothing different, not a big deal here. Okay, so let's go back to my lab. I have already renamed this, and I'm going to go to my make file that will be doing all the magic here. So I'm going to go to say make lab1. And there we go. The make file will do all the job and will be capable of seeing what is the status of our project. Right now, the current status of the project will be make status. Oh, sorry about that. And you can see that observability is being disabled. Geez, I can't read. All OpenTelemetry collector is being not configured, and the observability stack is not existent at this moment. So the idea is just deploy my agent. Let's go back a little bit. As you can see, the expected outcome can be seen in the documentation. And now that we have seen that, you can add the command code docker compose.yaml to see the structure, the current structure of the YAML file. We can skip that just for the sake of the time and go a little bit down to start playing around. You can pick the provider for the model you want to use. In this case, we don't really need to change it because the default is Ollama. You can see the configuration here that we just saw in the environmental file. And once we have picked the Ollama model, we can go to pick the second command we need to run, which is make docker up. There we go. And we just need to wait a little bit for that to be deployed. In the meantime, while the images are being deployed, we can go a little bit down and see that there is one second command we need to add. The second command is make docker logs. But something important. I know that we almost never read the instructions, but this instruction is quite important. We need to run this command in a separate terminal. So what I'm going to do is close the ChatGPT window, and I'm going to add a new terminal. There, I'm going to put make docker and logs. There we go. As you can see, we can have an expected outcome like if we were playing with Docker Compose. Not a big deal. So now that we have everything up and running, you can start checking the health of the application. We are going to copy this part. Crawl. I think I copied the comment. We don't need the comment. There we go. And I'm going to go back to my first terminal. Add the comment. And with a lot of imagination, you can see the result here. As the same way, you can see it in the expected response. What we can see here, I don't know, I think I can have a zoom. Zoom, there we go. Okay, maybe we can close this part to have more space, the expected response, and we can see it. Maybe we can clean to have more space, and probably you can see it a little bit better. Now that we have the expected outcome for the health check, we can start playing around with our bot. So I'm going to clear my terminal again and type make docker CLI to start playing with my agent. So the idea is now I can start asking some questions. The suggested questions here, we have some simple questions, and will be, hello, how are you? Not a big deal. We can wait a little bit. Remember that we are running a local model, so we can go grab a coffee, drink it. We can go get a tea and go back to get the response. Now that we have this, now we can start making some questions more focused in what matters to us. So maybe we can put, why is observability important? Look, I typed observability in a really fast way. I practiced the whole night for that word. So there we go. We can wait a little bit and see that we will get our response. Now that we get our response, again, we need to wait a little bit. We can just suspend our application and go back to our logs. Just, there we go. We have the answer. So we can put Control-C here, suspend the application, and you can see that there is some more documentation there that you can start reading and see what we have. Now that we have already killed our agent, we can go here to see all the basic telemetry we are getting. The basic telemetry we are getting is just the ordinary average Docker Compose information, nothing beyond that. Once we have done this, we can close this terminal and go back to our original terminal, clear it, and move to laboratory number 2.
Okay.
So far. Any questions? If someone is following, if you have any questions, just let us know, and we can go to your place and see what is happening.
Sorry. Okay. So if you scroll down to the bottom, and if you click on Lab 2, so the next step is to implement basic observability. So what that's going to do, basically, we're going to be deploying the OpenTelemetry collector. We're going to be deploying, well, actually, that's, we're going to be deploying the OpenTelemetry collector, and also we'll be deploying the OpenLIT SDK instrumentation. So you're not familiar with OpenLIT. It runs on top of OpenTelemetry. And basically, it's an SDK that allows you to collect different observability metrics, traces, or logs. And then you can push those into whatever backend that you choose to. For our case, we're using OpenTelemetry collector. And for Lab 2, right now, we're not forwarding them to any backend, such as Prometheus or Tempo. So right now, everything is running in debug. So I'm going to walk you through step-by-step on how that works. All right. So the first thing we're going to do is we're going to bring down what we did on Lab 1. So let's do that. Make Docker down. So we're stopping the container. And then you're going to do make lab 2. So now if I do the make status, you will see that the OpenLIT integration has been enabled. We still don't have PII masking, which that's for later for lab 4. We have the OpenTelemetry collector configured, and right now we just have the basic observability stack. So if you look into the apps API main.python, so for the OpenLIT, when we're auto-instrumenting, it's very, very simple. So it basically just takes two lines. We're just importing the library, and then we're just initializing it. And we're passing in this parameter to capture the message content. Basically, we're just telling the SDK to, hey, yeah, whatever you can find, just capture it and forward it. And then, if we take a look at the OpenTelemetry collector, this is the configuration. Basically, what we're saying is that we have one receiver, which right now we're receiving on two endpoints, either HTTP or gRPC. We're doing some processing. And then for the exporters, right now we just have defined a debug explorer that is giving us a verbosity of detailed. And when we want to basically define our traces and metrics, we're just saying that we're using that debug explorer for both of them. OK, so, and let's say, just assuming you want to export it to, somewhere else, like, for example, like Azure Monitor, right? You just do something like this. But we're not doing that today. OK, sorry about that. So now that we did our changes, right, and then we do Docker, make Docker up. And I'm going to do this real quick. OK. Yeah, it takes a little while to build the images. OK. And then on this side, if I do make Docker logs, you will see that we have, some logging coming from OpenTelemetry collector, right? So we're going to be doing the same thing that Amin was doing. So we're going to use the CLI, make Docker CLI, and we're going to interact with our LLM. Takes a little while. OK. So now that we got a response, you're going to start seeing all these debug statements from OpenTelemetry collector, as expected, right? So if I keep scrolling, you'll start seeing that we have different, traces and metrics. Obviously, this is not ideal on a development workflow, right? I mean, debugging this is just, too annoying. But I just wanted to show, how things are starting to get connected, right? So right now, we have our CLI talking to a backend, and then we're generating different metrics and traces, and they're getting pushed to the OpenTelemetry collector, and this is how they are, getting captured at this moment. Okay. And you can do more detailed logs, but I'm just gonna skip that for the sake of time. But what I'm trying to show is that some of these things that are getting captured are, for example, the input tokens, the output tokens, the token usage, the cost, the temperature. Everything related to our LLM application is being captured through that OpenLIT SDK. OK. So you can skip this. It's basically just into detail. All right. So now, that being said, we're going to move to lab 3. And for lab 3 is when it gets more interesting, because we followed the same pattern that we were just doing. Yeah, this mermaid diagram is not very nice on this screen, but basically, it's the same concept, but now we'll be expanding it, right? So we have all the telemetry data flowing into the OpenTelemetry collector, and then from there, we're going to send it to 2 backends, which is Prometheus and Tempo. And then from there, we're collecting that using like a Grafana dashboard. So let's get started. So I'm going to close this. Make Docker down. And then you can do make lab 3. And then you can see the make status. All right, so we have the OpenLIT integration. We have the collector configured. We have the observability stack configured as well, so which are the Grafana Prometheus tempo. That's what we wanted. And now let me show you the configuration for the OpenTelemetry collector. So this change, we have the same 2 receivers for OTLP. And then for the exporters, now we're saying, okay, well, we want to define this exporter into tempo, which you can reach at this this endpoint, which is tempo 4317. And then we have a Prometheus endpoint on this port as well, 9464. And then here we're saying, okay, well, if you're giving me traces, I want you to send those traces into tempo. And you're giving me metrics, I want you to send those metrics into Prometheus. Okay, so let's run make Docker up. All right, that was fast. And let's check our logs just to be sure. Yep, everything is good. So now, this one it gets really fun. We're gonna interact with our CLI. So I'm gonna type in make Docker CLI, and I'm just gonna start generating some data, right? So I'm just gonna talk to the chatbot. You know, just doesn't really matter what you say. How's it going? I'm gonna give some personal information. My name is Bob, and my email is I know it's a little slow. Okay. Hi, whatever. So by now, this flow should have made it all the way into Grafana. And one way to test this, if you click here under ports, you see that we have a port forward for Grafana. And if you click on this little globe icon, it's kind of hard to see. It will do the port forward, and we'll be able to see our Grafana dashboard. All right. So now we can start seeing some of our telemetry data. You can see that we had 4 successful GenAI requests. You can start seeing the request rate, things like the cost, how many total tokens we've used, the time to first token. That's important. It's kind of slow, but we're expecting that. Some of the request volume, request duration. But down here, you can start seeing the traces, right? And each trace represents each time we call the LLM. So if we expand on that, you can see that I cannot really see. Expand attributes. Okay, so we can see the prompt, that we sent, hello. And yeah, so it seems like all of this is working as expected. So that's great. And then I was going to show you this one. And this is the problem when we're using telemetry, right? Is that sometimes you can capture personal data that gets stored in our backend systems, and that's why we're here. trying to find that span that had our personal information. Oh, here we go. So yeah, my email essentially made it here, and it's not supposed to be here. So that's why we need to implement some privacy preserving techniques, and that's why I'm going to pass it on to Amin to continue for lab 4. Amin, are you ready?
Okay, so we have covered 3 of 4 objectives here. We have covered the agent deployment. We have also covered the telemetry we are sending, and we are deploying the telemetry. The problem, like Joaquin said, is that we are getting sensitive information in our dashboard. So the best way to work with that and handle is by using Presidio, an anonymizer tool that will hide this information for us. So I'm going to go back here to the terminal, stop the execution of this part, clear the terminal. Also gonna clear this terminal and get rid of it. Okay, it can be there, no problem at all. And what we can do is going to laboratory number 4, make it readable. And yeah, okay, let's start with number 1. Did you make Docker down or not? Okay, if we are not sure, we can repeat the command, make Docker down. Everything is being stopped. Just wait a little bit. And we're going to skip the first part, which is executing the project and seeing that the sensitive information is being deployed. The idea is repeating the last part of the project. If you are following the steps, you can play around with some of these prompts that will expose your sensitive information. And it is transparent. You don't even think of that part of sensitive information when you are typing in the agent. As a matter of fact, when Joaquin was typing, you saw that Joaquin was really close to write his email. So we don't usually think of that. It is like a common pattern that we all have. If someone asks your name, you're going to give your name like naturally, without a problem. So that's the reason why we need to add this anonymizer tool for all our scenarios. So I'm going to go back here to make lab 4. I'm going to clean my terminal, make lab 4. And after switching to this place, we can start first looking at the status. I'm going to clear again the terminal, make status. And everything is or will be enabled. Also, we can consider the PII masking tool being enabled. Okay, so now that we have already reviewed this part, we can go to this specific file. Oh, sorry about that. I'm gonna, okay, the mouse pad is, there we are. Oh, and it didn't copy that part. There we go. And this is the part where we are adding the tool that we are talking. So we have the part of the PII masker, and you can go all over the file where you can see how we are hiding this kind of information. As you can see, we have some specific fields where we can hide the information by putting a specific name for that field. So if we detect we have a phone number, we will have something like a phone into this field that we can identify. The idea is we want to hide the information, the sensitive information, but if we are talking about observability, we really need to see that the information is still there. So we can just see the file for phone, and we don't really need to concern about anything else. Okay, After doing that explanation, let's go back a little bit down to see the second file, which is inference. Let's go straight to the make docker up command to start deploying it. Make docker up. Wait a little bit. It's getting tired. Hey.
Perhaps you can share that how Presidio fits into this, like while this is running.
You want to share that part? I don't know.
So perhaps you can explain how Presidio
Yeah, absolutely. So there's different ways you can run Presidio, right? So in Presidio, you can run it as part of a container, or you can install like the Presidio SDK, which will download. It has a dependency on like a spacey like NLP model, which is the one that will allow you to detect like the personal information based on that model. That's why when he ran Docker Compose up, it was downloading that model, which I think is like 500 megs or something, and that's why it took a little while. So that being said, the goal here is to intercept that message before it gets picked up by the OpenTelemetry instrumentation. So it intercepts that, it masks it, and then it lets it go through the regular flow that we just showed before.
There we go. So I have already sent the first prompt. I am using a, yep.
If you're logging on a huge scale, is there or might there be a consequence of performance loss while anonymizing a lot of data?
That's an excellent question. I think that's probably beyond the scope of this talk. I mean, yeah, we can go on scale and performance. We didn't really frame it that way, but there's some implications in terms of performance. I don't think it'll be that much. It just depends how you get the Presidio deployed. If you're running it as like a sidecar, it's really fast. I don't know if that answers your question, but we can chat after if you want.
Something important we need to consider is, yeah, probably we're sacrificing a small percentage of performance, but we need to consider that we would like to prefer a secure agent that is handling the information securely, rather than a really fast agent that is not taking care of the information. Probably that trade-off is something we can think of. We haven't, at least in my side, I haven't identified like a big performance issue sacrificing this part of Presidio. So, okay, so as you can see, I have already deployed some of the prompts that you will see. And yeah, let's go to Grafana. The dashboard hasn't changed at all, but if we go a little bit down, we can check, here is the prompt. And I don't see the information.
You have to go through here in the spans. No, go up. It's here, like on span attributes. Up, down.
Okay, so here it is. And I mean, I cannot even see it in the monitor. You can get closer, but with a lot of imagination, you can see that in the span attributes, the fields of my name and the email,
Yeah.
something like this.
That's too small.
Yeah.
Basically, it did the masking for us, right?
This is so cool. If the demo would fail, you wouldn't see it. But anyway, you can see that the fields in the span attributes are being hidden. The idea is that no matter if I am typing my name or my email in the first prompt, or in the second prompt, my phone number, you will see the information. You will see all the data and telemetry that we want to gather and trace. But you won't see the fields for the name and the email. So that's the ultimate goal of this workshop.
Well, that being said, I think that concludes the demo and the presentation, and we have pretty good time for Q&A if that's okay, or if anybody's still working through the workshop and needs any help, we can definitely.
Something important, let's go back to the slide. There we go. And if you got lost and you want to get the repository, this is the repository where you can get the whole workshop. I mean, if you want to replicate it, something important that we mentioned at the beginning of the talk, but it is important to say that again, is that you can replicate the whole workshop without the needing of a code space on GitHub. You can use a dev container, so you can deploy everything locally. Maybe you will need a couple of extra steps like installing and serving the model that we are using in Olama, but not a big deal. The idea is that if you want to play around and replicate everything that we just did here, it's just a matter of a couple of commands, as you saw, and you can play around with it.
Does anybody have any questions? Yes, please.
Do you have a feeling how good Presidio is? I mean, you can't catch everything.
Right. So it's actually very good. I don't have those like numbers on me, to be honest, but it's really, really good. And the thing about Presidio is that you can define your own policies and custom attributes. So it's very powerful. I mean, from our experience when we've used it, even with customers, they've been very, very happy. And it's open source. So.
And benchmarks I've seen is the best open source one.
It is. Yeah. Yes, please.
Sorry, just a quick follow-up. So is it just a SDK library that you use?
Correct, and it's a library that uses an NLP model to detect these type of situations, and depending on the policy that you define, if you want to be keeping track of credit cards or social securities, like it will mask them for you, or you can block them all together as well. Yes, please.
It's used to send it to the observability tool.
I'm sorry?
If you do a prompt with an email address or a social security number, it's still sent to the LLMs.
It will mask it and then it will send it.
So the LLM doesn't see any.
Correct. Correct.
It's not only for the observability part.
Exactly.
Will it also trace, because that was a question I've seen, we've been doing pen testing on some systems, and we basically got back the open API keys on the response.
Oh, really?
So I was wondering, does it also blank info?
You can do that as well. You can put Presidio anywhere you want in your code and intercept that message and do whatever you need to do. Yeah.
So it's kind of a follow-up question of what he said. So that just make the data not observable but still usable?
Yeah.
Yes.
Yeah, because you want to get the credit card number because you want to do a payment transaction, but you just don't want to save it in the observability part because it is not that necessary.
Yes.
Do you only check if this data input, or do you also make sure that the backend code doesn't provide this information in case of any hackers try to get the information for the user? Because this is something happened recently that there was a hacker, they tried to do one of these vibe coding platform and they get all the information of the users out of
Interesting. Do you know the answer to that?
Yeah, well, we need to make a small test about that because we want to let the agent know what to do with the information. In the meantime, we are not saving the information for the observability part, but we haven't tried the agent giving the information back. I don't know if we're masking that part.
Oh, the response. No,
The response?
For this workshop, we're not masking the response. For the purposes of demo.
Yeah.
We're just doing the input.
But in general, you will mask.
You can, yes.
And that privacy information is also included authentications and user ID and this kind of things as well, I guess, right?
Mm-hmm.
Yep. Cool. Oh, yeah, sure.
I don't know if it's part of the scope of the workshop, but does that mean you, in terms of agentic system, have a whole different type of way of making the system where the agent knows the information, but it can't see it? So you have to make it reproduce or generate content based on how you're talking, but taking into account that it can't see the information because it won't view it, observability-wise. You know what I'm saying? Because the data still lives and it is there, but it won't display it to the user. So how do you make queries to the agent knowing that it knows the data, but it can't see, observe?
Yeah. Okay. Talking about Presidio, like Joaquin said, you can put Presidio in one specific part of your agent. So if you know that your agent needs the information to start a different workflow or something, you can let the agent get the information but not store it. That's the important part. Probably the agent will need your credit card number because it's going to make a transaction. So it's going to get the credit card number, it's going to do the transaction, but it's not going to store it. Or if you need to store your credit card information, it will store it in an anonymous way. So you can put the Presidio part in the part where you need to not saving it, but you can start playing around with the
You
information.
can encrypt it too.
That's what I'm saying, but when in the workflow, but then you have to give the information from one part to another part, but it's masked, right?
Well, in this case, we're masking, right? But there's some scenarios that you can actually encrypt it. So before you send it, you encrypt it. It gets sent to the end place wherever it goes, and then you know how to decrypt it, not the agent, not anybody else around. So.
Just like any ordinary application.
So you can even change the encryption, so to say.
Exactly.
Yeah.
Yes.
About composite personal data.
I'm sorry?
Composite personal data or data that becomes personal when it's combined. It's not personal at the first glance, but when you combine it, then
Wow, that's a good one.
Yeah.
Like what kind of information?
like zip code, I don't know, initials, different types of info that when combined becomes personal.
Okay, what you're saying is that we don't want to mask the zip code because it's like a public information. But if what I want to do is masking my zip code, right?
Yeah, data that's not personal, but when combined
Becomes personal. That's a good one. What about that? I mean, we haven't thought of composite data.
Well, Presidio is extensible, right? So you could write potential plugin.
Correct.
Sort of thing. It is limited. I've seen, especially when you go very deep into countries, I don't know, you go in India, there's specific type of AI there. It's not supported, but you could potentially extend it.
Correct.
So I'll just quickly address it because this is what I was covering in the morning session, right? So, and you asked about that how do you use, when you have the video. So today I had a session, I was speaking on a session. And
Do you want a microphone?
yeah, sure. So we were talking about the same thing. So I'll quickly tell you because in that session, I was how different ways you can anonymize the data and how the agent can do it, right? Presidio comes in two formats, right? Now, one, what you see right now, it is a pattern-based or what it is? It's a pattern-based, right? So there is a way how you can actually train your model. But again, with Presidio, by default, there is a YAML policy which can be configured. Now, in the morning when we were trying to say that how multiple agents can work together, at that point, what can happen is, for your question, and then I will come to your question. For that question, for example, let's say they both are from Microsoft, right? And now they say that, okay, I want to know how much is their expenses that they have done for this trip. But for that, what should be the organizational policy? They will get only about for their corporate number or the corporate ID number, which is not masked. Every other thing, their personal identifier, their personal number, everything will be masked. That is based on a policy. So you can set your own policy and procedure, either through an LLM-based model, which can talk to you, or you can set the policy again through a regex thing. Now, to address that, the question that you asked, right? So the thing is, let's say in a group, like what his question was, that in this group, let's say that how many, okay, who is that person who has come from Mexico from Microsoft? Like, I don't know. Who is that person who has come from Mexico and also at Linux conference? Amin, right? You're from Mexico, right?
Yep.
So this is how you do it, right? So the best thing is, again, from a policy framework, policies are going to be very important as and grow, like as and when you are building your LLM system. So think in this way, that whatever you see as a procedure today, it's not just an anonymization tool. It's a policy which will be enforcing that, anonymize this much data and use that much data only. You spoke about India, right? The same thing. India has only 6 PII. UK, in the UKI policy, they have 38 PIIs. So when I give my record, an Indian record, and I say that, okay, take this document and give it back, it will have a hell lot of information. But the same way, if you put the policy and then writing that policy, if you push the same data, which is following the UK policy, at that time, all those 36 identifiers will be identified, mask it, and then it will go to the LLM to process. Just thought to share this up.
Yeah, no, thank you so much. Yeah, we became friends this morning, by the way.
Yeah.
So it's not like he's some random that, oh, yeah, no, we were friends, so. All right, any other questions? Yes?
Could you use, instead of Presidio, just a custom small LLM to rewrite like the whole input, and then have it like also have your list of rules?
I haven't tried that, to be honest, so I won't be able to answer that question.
I did try that. So.
Hey, I need to put you on the talk now.
All right. So I have tried that. So my first thing was, because Presidio, if you look at it, who was talking about the memory? You were talking about memory, right? Performance, right? So again, if you Presidio as a library, when you use it as a library, you do a pip install, right? But again, think of it as a service. When you think of it as a service, you have to run it as a container, right? So my idea, the same thing what he said. Like, is Presidio that smart? Why don't I use a simple Llama 3.21b and try to do it? But again, when we look into it from a policy perspective, the way Presidio works, it's not, because you have to define your entities. And when you define your entities, you are creating a lot of time creating the prompting and say that, okay, try to understand it. And sometimes the prompt, if it is not there, you are not only going to give a prompt, but again, with that, you're going to give your policy. And one more thing. People think that, okay, if you're using a 3.21 billion parameter, it's very easy to do it. But the problem is, the longer the prompt, it means longer the instruction. Longer the instruction, you will have to change the parameter tune. By default, most of you must be trying with OLAMA, which is just on 4096 characters. But if you want to use it, the same 1 billion parameter will spin up to a 6 GB, taking 6 GB of your space. So the best thing is you can do it. Or otherwise, there is the today morning when I was showing, you can use the JEMA 270M model, create an intent, and use that with the procedure policy. If you both work them together, then that becomes your perfect way to handle it, because it is a CPU intensive. The JEMA 270M is like a complete CPU intensive, so you can work that in that model. So to address that, yes, I have tried it. So you can go with 270M.
Oh, you can say here if you want.
Yeah. Thanks, Krish.
All right. Anything else? I think we're good. All right. Well,
Cool.
thank you, everybody.
Thank you so much.